8.1, we are looking at an introduction to statistical tests. So we're going to have a lot of parts to the statistical tests. We're going to pretty much do statistical tests all through Chapter 8, and it all just uses your calculator. So as long as you have your calculator and you remember your steps and what to type in, this should not be very hard for us to go through. But you just got to remember what to use on your calculator when you go through it. So every time, what we're going to be looking at is a null hypothesis, that's the H sub 0, the alternate hypothesis, the H sub 1. So for your null, this is a statement that's under investigation or being tested. Usually the null hypothesis represents a statement of no effect, no difference, or things haven't changed. The null hypothesis is often a historical value, a claim, or a production specification. The alternate hypothesis, then, this is the statement you will adopt in the situation in which the evidence is so strong that you reject the null. A statistical test is designed to assess the strength of the evidence against the null hypothesis. This is the hypothesis to be accepted when the null hypothesis is rejected. So we use hypothesis testing to see which hypothesis is correct in an experiment. So we have different tests depending on what we are told in the problem. Your null hypothesis is always going to be mu is equal to whatever the value is for that historical mean. Now, for our alternate hypothesis, we've got three different things. We either are going to have mu less than, mu greater than, or mu doesn't equal. If it's less than the value stated for the null. If it's greater than, we're saying it's more than the value for the null. If it doesn't equal, then we're saying that it's different than the value. Now, each of these are called our left-tailed, right-tailed, and two-tailed tests, too. So sometimes you might see those words pop up on your web assignment when you go through it. So here, for example, 1, a car manufacturer advertises that its new subcompact models get 47 miles per gallon. Let mu be the mean of the mileage distribution for these cars. You assume that the manufacturer will not underrate the car, but you suspect that the mileage might be overrated. So for your null, so our mu is going to be equal to then our 47. So then for our alternate, it says you suspect that the mileage might be overrated. So you think 47 miles per gallon is too much. So for your alternate, you're going to say less than 47 because you want to say that it should be less than that 47 miles per gallon. So we are going to be looking at hypothesis tests. The first one we look at is testing the mean, the population mean, given that x is normal and we know sigma, that population standard deviation. Now going through this, they're going to give you formulas. As I said, you do not have to do anything by hand. Your calculator will do everything for you. So I'm going to give you formulas, but you don't have to even use these. The main thing you have to know is how to go through the test and type everything in your calculator. Right now I'm just explaining all the parts of the test. I will show you how to type it into your calculator also. Now you're going to be finding a p-value. It's just like you did when we went through chapter 6 and we wanted to figure out, once we knew our z-value, what's the probability. That's what you're looking at here. We're trying to find the p-value or the probability that something occurs. So for your p-value, assuming the null is true, the probability that the test statistic will take on values as extreme as or more extreme than the observed test statistic is called the p-value. The smaller the p-value computed from the sample data, the stronger the evidence against the null. Now here they give you your picture for your left-tailed, right-tailed, two-tailed test. Again, you will not have to find any of this by hand, but I want to make sure I show you what they mean. If you have mu less than, you're going to have a left-tailed test. So you're coloring to the left of your z-value. If you have a mu greater than, you're going to be coloring to the right of your z-value. If it doesn't equal, you are saying both directions. That's why it's two-tailed. So you're coloring to the left of the negative z, right of the positive z. And as I keep saying, your calculator will find everything for you. Now, you do have some types of errors as you go through this. They list a bunch of stuff for you. The important one to remember is our alpha. Alpha is called your level of significance. Now, with your level of significance, it's called a type 1 error. That's this one right here. So that type 1 error occurs if we reject the null as false when really the null is true. So many times they're going to say, find the probability with a level of significance of 5%. So there's a 5% chance that we state the null is false, given it should have been true. Or they might say, find the level of significance with a 1% chance then. So you have a 1% chance to reject the null when really you should say it's true. Now we conclude a test. Once you know what your alpha is, if the p-value you find is less than, we can reject the null hypothesis and say the data are statistically significant at level alpha. If it's greater than alpha, we're going to fail to reject the null hypothesis and say the data is not statistically significant at the level alpha. So statistically significant, it says that at the alpha level of risk, the evidence against the null is sufficient to discredit the null, so we can adopt the alternate hypothesis. In any case, we do not claim we have proved or disproved the null hypothesis. We can only give the probability of an error of alpha. So you're technically not proving one way or the other because there's still a slight chance that you could have found it incorrectly. So you're not proving one way or the other. So a lot of the times they're going to give you an alpha of 0.05 or 0.01, as in 5% or 1%. So if it is a 5% level of significance, this means that in 100 similar situations, the null will be rejected 5 times when it should not have been rejected. And here they give a little meaning as to fail to reject and reject. If you fail to reject, there is not enough evidence to justify a rejection of the null. If you reject, there is enough evidence to justify the rejection. You will have to write a sentence at the end of every single one of these explaining what you find. So it's pretty much going to be the exact same sentence no matter which way, either fail to reject or reject. One will be statistically significant, one will not be. So you're doing the same thing, but you're just going to add a not or no to your sentence. So here is the list of everything that you will see. So you're going to state the null, alternate, and alpha. You're going to give your test statistic, your p-value, your conclusion, and then your sentence. So we're going to first start with this z-test. With the z-test, we're going to test the population mean, but we have to know our sigma. So we must know the population standard deviation. So when we go through that, this is all stuff that's going to pop up for you. So you're going to hit the stat button. You're going to go over to test. You're going to look for z-test. Now, the nice thing is this is the same group you're going to look at for this whole chapter 8. So it's always going to be stat, go over to tests every time. So if you're stuck, stat, test, choose one. So we want a z-test for this one. Now we are going to go through it, and we want to click on the stats when we go through it. So again, we're going to hit stat. We're going to go over to your tests, and you want the z-test. That's the first one for me. Now it says data or it says stats. If you move over to stats, depending on what's in your calculator, numbers might start popping up. Because if you have done statistical computations under your L1 and you went the stat, calc, 1var stats, the 1var stats automatically pop up if you have the stats on there. So if you ever have to do that, it's already plugged into your calculator for you for some of the numbers, which makes it really nice. Okay, so the mu is going to be your value for your null. Your sigma is your population standard deviation. X bar is your sample mean. N is the number in the sample. And then mu, you're going to choose your alternate hypothesis. So that's there for us. So keep that up, and we're going to go through example 2 together. So Rosie is an aging sheepdog in Montana who gets regular checkups from her owner, the local veterinarian. Let X be a random variable that represents Rosie's resting heart rate and beats per minute. From past experience, the vet knows that X has a normal distribution, sigma equals 12. The vet checked the Merck veterinary manual and found that for dogs of this breed, mu equals 115 beats per minute. Over the past 6 weeks, Rosie's heart rate is measured. The sample mean X bar is 105.0. The vet is concerned that Rosie's heart rate may be slowing. Do the data indicate that this is the case? Use a 1% level of significance. So going through this is how you're going to see all of your quizzes for me. This is going to be how all your tests are set up. So I want to make sure you see the exact same wording every time. So I'm going to first ask you, what's the level of significance? It's 1%, so that means it's going to be 0.01, because you always want to put it in decimal form. Now for your null and your alternate, these are going to start mu and mu. Now for our null, since they told us usually it's 115, we're going to have 115. However, they think that Rosie's heart rate could be slowing, so we are testing less than 115. Now for number 3, they want to know the value of the sample test statistic. This you only can find on your calculator. So after you do steps 1 and 2, we're going to go over to our calculator and fill things in. So when it says mu sub 0, remember that is your null hypothesis, so 115. Then our sigma, look back at the problem, they tell us sigma is 12. Now for our X bar, they tell us 105. For our N, count up the number of numbers you have. 1, 2, 3, 4, 5, 6. Because it's 6 weeks, sir. So I've got 6. And then we just said less than. So you want to find less than. Now you don't have to worry about drawing or colors or anything. You want to go down to calculate. And you want to hit enter. So it's giving you all the information that you need. They're giving you your Z value. That's your sample test statistic. So we're going to do negative 2.04. Next, they want the p-value. So we want 4 decimal places. So 0.0206. Now when they say reject or fail to reject, you want to compare your p-value with your alpha. P-value is always going to go on the left. Alpha is always going to go on the right. And our alpha was 0.01. Now 0.02 is greater than 0.01. So if it's greater than, we're going to fail to reject. So we cannot state what we're trying to find. We're saying there is not enough evidence to state that her heart rate is slowing down. We don't have that. We can't say that her heart rate is 115. We can't say her heart rate is slowing down. We don't have enough evidence. So when we write that sentence, we would say, at the 1% level of significance there is not enough evidence to conclude that Rosie's average heart rate is slowing. And yes, you need to make sure you write out your sentence. I need to know what's the level of significance. I need to know, is there enough evidence or not enough evidence? And then to conclude what? What were we talking about in the problem? Now, if we rejected the null, we would just not put the not in the sentence. So it'd be the exact same sentence, just erase the not part. So you write the same sentence, except one has the not in it, one doesn't. Now I want you to try the next one. See if you can go through it just like we did and find all your parts. So pause the video, go through your calculator steps. If you need to go back, look at the notes and fill in everything. Okay, so we should have answers here for this one. We have the Environmental Protection Agency has been studying Miller Creek regarding ammonia and nitrogen concentration. For many years, the concentration has been 2.3 milligrams per liter. However, a new golf course and new housing developments are raising concern that the concentration may have changed because of lawn fertilizer. Any change, either an increase or decrease, in the ammonia and nitrogen concentration can affect plant and animal life in and around the creek. Let X be a random variable representing ammonia and nitrogen concentration in milligrams per liter. Based on recent studies of Miller Creek, we may assume that X has a normal distribution with our sigma equal to 0.30. Recently, a random sample of 8 water tests from the creek gave the following X values. The sample mean is X bar equals 2.51. Has the concentration of ammonia and nitrogen changed from 2.3 milligrams per liter? Use a 1% level of significance. So 1 should be 0.01. Null and alpha. So it has been 2.3. So 2.3 is our null. We want to know if it's changed. If it's changed, it doesn't equal 2.3. Now that we have our information, we want to go and do our test. So we're going to hit the stat button, go over to test, and we want z-test. Okay, still keep it on stats. We're going to go down. Our null hypothesis is 2.3. Our sigma was 0.3. Our X bar was 2.51. And our N, they told us there were 8 tests. So N is going to be 8. Now for our alternate, it was doesn't equals. So you want to hit enter for the doesn't equals. Again, just keep scrolling down. We'll go down to calculate. So there's my list. So for my Z then, it's a 1.98. For our p-value, 0.0477. So if we compare .04 is greater than 0.01, so we're going to fail again. So now you're going to write your sentence. At the 1% level of significance there is not enough evidence to conclude that the ammonia nitrogen concentration has changed in Miller Creek. So again, you're going to pretty much do the exact same thing every time when you go through these. For our next couple sections, it's going to be the exact same steps. You're going to write just about the exact same sentence. You're either going to have the not or you're not going to have the not. The only thing different is the test that you run. So it's still the exact same steps. So if you can do 8.1, you can also do 8.2 and 8.3 because everything is going to be pretty much the same with typing stuff in.